For the third step in our example, let's see if we can make some sense of these refined results by kind of looking at the visualizations, kind of plotting some different things on the axes, and just see if we can kind of figure out what sort of things are affecting the view 1 and view 2 variables and the outputs that we'd like to maximize the most. So let's go back over. I've run a couple different studies here. This first study is the one that varied all the different locations, so left all 12 variables floating. The second one down, I went through and isolated that, so I was only letting the buildings 1, 2, and 3 kind of float around a little bit. There's still quite a few variables, but let's see if we can sort of make some sense out of it. If I try to plot view 1 in one direction versus view 2 in the other direction, oh, that's kind of interesting. We sort of, looks like we have some sort of a trade-off here between the different points that are sort of either maximizing view 1 or view 2. It's interesting that, okay, well, but potentially 180 different views in the view 1 direction, potentially 80 different views in the view 2 direction. Let's go ahead and plot that. Well, let's do decreasing by view 1. Sort of see what this point looks like. It looks like it is this case. Might actually be two cases there. But we seem to have an awful lot of rays kind of heading off in the view 1 direction. A lot fewer that way. So that might be, if we were really attracted to view 1, an interesting case to sort of think about. Okay, it looks like this one might actually be, is it the same? Let's kind of think about it. There might be just several points that are really right on top of each other, or those might actually just have the same values in terms of what was available. So it looks like we see a whole range of them that are kind of doing the same sort of thing in terms of view 1. Very good. Let's have to catch up with us a little bit. Let's kind of think about the ones that instead maximize view 2 and really what's happening there. So it looks like for the view 1 strategy, there, I think we're caught up now. If I come back over here to the Dynamo window, I can preview it there too. Those are the view 1 cases that are doing the best, kind of keeping these middle buildings relatively close together. We're blocking the back buildings, but we're actually providing a very nice view, sort of spreading out those two front buildings and bringing those two middle buildings in as close as possible. Okay, let's try the other extreme. Let's try view 2. And it should be somewhere over here. Again, giving Dynamo a chance to catch up with us. No, there's an awful lot of rays being computed here. That's why it's going through and taking a while to go through and regenerate this. Ways we could enhance this analysis if we want to keep on going. We could sort of associate some sort of a value with the view towards view 1 versus view 2. Let's think about this. Did it update yet? I don't think it's updated yet. Oh, maybe it has. So in this case, at least we're seeing it back over here, you're kind of seeing that we have a lot of views towards view 2 from this back building over here, kind of looking around these two. Okay, relatively few over here. Okay, and there's a lot of different sort of potential cases to kind of look at here. So we do have like some variability in here. I was starting to comment that if we wanted to go through and change these, we could go through and come up with a weighting value to sort of kind of say that there's something more attractive, or to kind of help us understand really where we want to be somewhere along this frontier. But that seems to be the outer frontier. Again, we can run this several different times. We can start to think about really some specific values in here in terms of, the total number of views from view 1, versus view 2. Okay, and the different cases that bring us those things. We could also come over and just look at really what sort of gives us that maximum of view 2. So to maximize view 2, basically we have the G2, G3, X values. You can sort of plot through really what it takes to go through and do that. Okay. If we try to switch that over to what? Kind of contrasting it to other values right now. So those are maximum of view 1. We could start seeing really how all the different variables would change relative to that. And this might give us a sense of really what of these different values are the most important to change. It seems, for example, like the y values of G2 and G3 were not changing very much at all to get these good results. But to get the good results for view 1 and view 2, it's interesting. You know, this one, yeah, view 1 is very good, but view 2 isn't so good. If I sorted those by view 2 instead, you know, there's the best case on view 2. You can start to see, you know, which one you think gives you the best balance. This is sort of even for view 1 and view 2. That's slightly biased towards view 2. That's definitely biased towards view 1, as opposed to this is getting more and more strong for view 2. Okay, and the values that are there. Okay, so you can definitely kind of complete the analysis that way. You could also go through and look at sub-studies of the analysis. This is really looking at a smaller kind of subset of the data. This was really just looking at, kind of bring the scatter plot back up. Oh, it was really just, again, view 1 and view 2, but only changing a small number of variables. Okay, and this was really all about just changing, I'm trying to remember, the y values of those 3 different buildings. So we see if we change the y values of those 3 different buildings, there's really only 2 data points that are available to us there. There is this data point. Okay, it's either 80 or 90. So there's only one case over there. Well, actually, it sort of converged very quickly. So if we're only looking at those, you can sort of see what it considers to be the best, if those are the only variables you want to look at there. So there's this notion of you either can basically do 145 view 1s and 80 view 2s, or you can have 90 view 2s and 135. So not much variability there. There's a whole lot of different combinations. Well, not a huge number of combinations that could potentially give you that. But this is if you want to start sort of subdividing the problem and kind of conquering just by kind of decomposing it a little bit. So again, this whole example is really just all about how you can go through and use this sort of ray analysis to go ahead and take a look at views. That's very useful for a lot of different cases, you know, whether you're thinking about how either you're looking at things or how whether sun rays or reflections or people having a view into your building or, you know, your privacy or just all these sort of different issues that are addressed by kind of whether something is blocking a ray or not. So this example might be the basis for thinking about a lot of different optimization problems that are related to those issues.